me to start this course for signal processing for millimeter wave communication for 5G and beyond. And this is assignment for, sorry, this is, okay, it was for 8 and let us start. So the first question here is, the singular value decomposition of a matrix H is defined by H is equal to U, E and V star. And the question asked here is about what is the diagonal elements of the matrix E, that is given 0.3 and 0.4, and the trace of the matrix H star, it is required. So let us define the problem first, and then we can sort it out. The first question is given as a matrix is given H, and it is said it has a singular value decomposition of this sort, U sigma V star. So this U is a unitary matrix and V star is also a unitary matrix, and this epsilon, this is the eigenmatrix. So if I think about H star, it becomes U epsilon V star, and if I take the conjugate of these, it becomes like H star is equal to V epsilon star U star. So it comes V epsilon star and U star. So these terms comes as the identity matrix. So whole terms comes as U identity matrix U star, and there is the, sorry, it's wrong. This epsilon is here, then the identity matrix, and this is epsilon star and U star. So this is U epsilon epsilon star and U star. So as these are the unitary matrices, so if I take the trace of this system H star, it becomes the trace of epsilon epsilon star, and it is said the diagonal elements of epsilon is 0.3 and 0.4. So diagonal elements of epsilon epsilon stars will be like multiplication of this matrix with the same matrix. So trace of this is like trace of this matrix 0.9 square, 0.9 and 0.16. The multiplication of these diagonal elements happen, and if I take the trace, it becomes 0.25. So the answer is option C. For this question. question is, a WebDM system has n samples within one symbol and the considerable channel length is L. So the question is, what is the minimum length of the cyclic prefix? So if there are n samples within one symbol and considerable channel length is L, then it is asked what is the minimal length of the cyclic prefix should be. So to make the channel circular symmetric, we know that the minimum sort of thing that we require is the channel length is L. So minimum length of the cyclic prefix should be L to make the channel circular symmetric. So that is the reason the option is option 2A. This is the question number 2. The option is option A. Now come to the question number 3. Question number 3 is asking, there is a WebDM modulation and this is for sub 6 GHz WebDM modulation, and what is the reason we use the WebDM modulation? The first option is option number A, that is ISI, intersymbol interference in this case. The second option is carrier frequency oscillation problems. The third option is Doppler effect of the channel, and last option is all of the above. So the reason we use the WebDM kind of thing, it's such that one of the signal does not interfere with the another one in the time domain. So if I think about the interference in the time domain sense, in this case that is intersymbol interference, and we know that carrier CFO problem, there is also a problem for the WebDM case, and Doppler effect of the channel cannot be has nothing to do with the WebDM type of thing. Like if the channel changes within a certain interval, we have to do the channel estimation again, and we have to do all the process that we do in the receiver. So Doppler effect of the channel cannot be mitigated by WebDM, and carrier frequency oscillation can also not be. The only option is ISI. So the right option for option number A is the ISI problem. So question number 3, right option is option A. Now let us go to the question number 4. So question number 4 says, which of the following is the advantage of the WebDM? So the first thing is we do not need to perform inversion of the non-diagonal matrix of the data direction based data direction in receiver end. So it is true, like if there are some equalizer, we have to use a inversion matrix. If we use zero force equalizer, that is the channel matrix H inverse. If we use LMMAG based equalizer, then we also have to use some inversion of the correlation matrix to estimate the actual value of the X. So if I use the WebDM, the like for a CISO system, it comes as a diagonal matrix, and for that we do not need to do the part. We don't need to perform the inversion of the non-diagonal of the matrix, that H matrix. So that is the easiest path for WebDM, and obviously there is no ISI problem. And option number C, it converts frequency selective wideband channel to narrowband subcarrier, each exposed to flat fading. This is also true. Like why we use the WebDM? Like we use the WebDM so that we do not need to do the equalizer part of equalization of the channel. Like that is some memory of the channel that is getting added in the next interval, and if we use the WebDM kind of thing, each of the part works like a parallel path. So the right option for question number 4 is all of the above. That is option number D. Next question, question number 5. Question number 5 says, for a FDM system, each FDM symbol carries n samples, and let us assume uh, the transmission bandwidth of FDM symbol is 100 megahertz, and the coherence time is 0.067 microsecond, and the delay spread of the channel is 0.0117 microsecond. So the question that is asked is, what is the value of the n begin? So let us solve this problem, and first let me tell what the problem says, and one by one I can solve the problem. So question number 5, it is, question number 5 says, we said, what is the transmission bandwidth? And the transmission bandwidth is 100 megahertz. And the symbol duration, that is also given, that is 0.001 microsecond. What else is given? What is the coherence time of the channel? And that is 0.067 microsecond. Okay. So, if there are n number of samples in a FDM symbol, and probably there will be some subcarrier there could be. If I think that the total symbol should be in the 2 to the power n factor. So, what is given? Symbol duration. And what is given? The coherence. So, within a particular coherence time, how many symbols can be sent? This depends on this factor, and if we derive this factor like this, like what is the total coherence time, that is Tc, and within this Tc how many symbols can be there, so that is by Ts, so that is 67. So total 67 symbols I can at least send within a coherence time Tc, right? So within one coherence time, like the coherence time, we can send 67 symbols. But I have a catch, because I have to do FFT and IFFT, I can only send in the 2 to the power n factor. So how many data I can send? The nearest is 64. So the n should be here 64. So let us check the options. So see the option number B. Option number B says it is 64. So the value of n should be 64. So for question number 5, it is option B. So question number 5, it is option B. So let us go to question number 6. Question number 6 is asking, the CFO in FDM system decreases signal to noise ratio and keeps signal to interference plus noise ratio constant. So basically it is saying which of the following is true. And the second option is decreases signal to interference plus noise ratio only. The third option says decreases the signal to noise ratio only. And the fourth option says decreases the signal interference plus noise ratio, but SNR remains constant. So what is COP? COP is the carrier frequency oscillation. So if I have some sort of CFO here, CFO does what? CFO, what it does is actually CFO. So this is carrier frequency offset. So the thing it does is just a mismatch of the phase, and for this, if the carrier frequency is not exactly, it should be demodulating the signal. What it does, another signal can interfere with another one, so it does interference. Now if I have a signal, and what happens in the wireless channel, noise is mixed with it. In this case we can define the signal to SNR as signal to noise ratio. But if there is interference, there is another term, that is interference. In this case, we define it as SINR. So this is signal to noise ratio, signal power by signal power by noise power plus interference. So CFO does not like does not generate any extra noise. What it does is it is adding up some interference, right? So for such case, it is said that this decreases signal to interference plus noise ratio, but SNR here, signal to noise ratio, that remains constant. It decreases signal to interference plus noise ratio, but it does not decrease the SNR. So the right option is D. So let us go to the seventh question. The seventh question says, for a WebDM system, the transmission bandwidth of WebDM symbol is 65 MHz and the subcarrier spacing is 1 MHz. If the input of the WebDM system is coming from a QPSK constellation, then what is the data rate? So they are asking about what is the data rate. They have given the transmission bandwidth and they have given the subcarrier spacing, that is 1 MHz. So let us derive this question. Question number 7. So what is given here? The first point that is given here is transmission bandwidth. Okay, so the transmission bandwidth is 65 megahertz, and subcarrier spacing this is what? This is 1 megahertz here. So this is the total bandwidth for a FDM symbol, and each of the subcarrier has a difference of 1 megahertz. Each of them is like taking 1 megahertz for subcarrier. If I think this is a signal, there is 1 megahertz and this. So total subcarrier spacing is 1 megahertz and total transmission bandwidth is 65 megahertz. So how many subcarrier can I gather in one FDM symbol? That is maximum of this by 1. Less than this, n is, because total bandwidth is 65 megahertz and the spacing of two subcarrier, this is first subcarrier, this is second subcarrier, this is third, each of them has a bandwidth of 1 megahertz. This sort of thing we can think of. So total is 65 by 1, so I can say it is at 65, but this n should be at 2 to the power n factor. So it should be 64, right? Now the question says the data is coming from a QPSK constellation, and we know one QPSK constellation says for one constellation I send a I and Q part. So I, this contains one data, this contains second data. So one QPSK contains two data, and total 64 carriers are there. So total data is 64 into 2. So this is 128 bps, bits per second. So let us check what option is there. So option number C, that is 128 bits per second. So this is option number C. Okay. What is the QPSK constellation? It has 4 data points, right? That is 0, 0, 0, 1, 1, 0, and 1, 1. So whenever I am sending one QPSK, actually I am sending 2 bits. It is either 0, 0, 0, 1, 1, 0, or 1, 1. So for each QPSK, I am sending 2 bits. And how many QPSK I can send? I can send 64 subcarrier. For each subcarrier, I can send 2 bits. So there are 64 subcarriers. So total bits I can send is 64 into 2. That is 128. So that is the reason it is 128 bps. Is it clear? Okay, thank you. The next question is, there is a MIMO FDM system and the transmission bandwidth of the FDM symbol, and that is 2 cross 2 MIMO FDM system, and it has 16 sample in one FDM symbol for both antenna. So there is a 2 cross 2 MIMO FDM means there are 2 transmitter and 2 receiver, and the system has 16 sample. I mean, in the big N is 16. So the considerable channel length, that is H11, H12, H21, H22. So there are two, this is 2 cross 2 antenna system. So if it is 2 cross 2 antenna system, there will be 4 channel parameters, like the first antenna to first antenna, first antenna to second antenna, second antenna to first antenna, and second antenna to second antenna. So they are defined by H11, H12, H21, and H22. And each of these paths has, the first path has 2 taps, the second path has 3 taps, the third path has 4 taps, and the last one has the 3 taps. So this is question number 8. So what should be a CP length here? CP length should be length, this should be maximum length of all the taps that are present, that is H11, H12, H21, and H22. So the first has 2 taps, the second has 3 taps, this has 4 taps, this also has 3. So the minimum of the CP length should be maximum of all these paths that is existing in the MIMO system. So what would be? It will be 4, because 4 is the maximum number of taps for H21. It is. So the correct option will be option, let us check what option will be better. So this is D, option D. So that is 4. So let us go to the question number 9. Question number 9 says, a millimeter wave MIMO evidence system has n sample in one WebDM symbol and k cyclic prefixes. So the total WebDM symbol has n sample of the data and k cyclic prefix. And it is said the DAC sampling frequency is FD Hz. The question that is asked, a particular beam should not change for how much time? That is what they asked. So let us solve this problem. This is question number 9. So it says, what is n? N is here data sample and actual data sample without the cyclic prefix in one WebDM symbol. So this one WebDM symbol, it has k cyclic prefix. If I can think so, like that. Because in the end we'll discard the cyclic prefix, so that does not matter for us. So that is said, n is the data length, WebDM samples in the WebDM symbol, and k is the cyclic prefix. So the DAC, what it does? So in the beginning, it will come the digital data will come. It will be converted to analog. So for one WebDM symbol, I have to wait. This DAC is processing the data actually. So that processing of it requires to process one data. How much? That is 1 by 80. If the frequency is 80. So for one FDM symbol, that should be within one coherence time, and it should not change. The beam should not change for that duration. So if I think like that, to process, I have to process n data sample plus k cyclic prefix, and the total time that is required is, for processing one data, this much second is required. So if I think about this, it will be 1 by 80 second. So it is like 1 by nk by 80. So right option is option number B. Let us go to the last question. The last question is, which of the following should not change for millimeter wave MIMO FDM system within the coherence time? The first option is angle of arrival of the signal in the receiver. The second option is angle of departure of the signal uh, in the transmitter. The third option is channel coefficient gain alpha. The option D is all of the above. So for a MIMO FDM system that is inside the millimeter wave, the MIMO system that is implemented by digital precoder, and this digital precoder is inside the system here. So whenever I am transmitting a particular beam, within that particular beam, I should send the whole WebDM symbol. So within the particular coherence time, that is the duration of the WebDM symbol I can think of, or multiple 2 or 3 WebDM symbol. Not, I should not change my beamforming pattern. If I change my beamforming pattern or anything that happens in the wireless for millimeter wave, so if I change the angle of arrival, if I change the angle of arrival, the beam pattern will change. Like if the angle of arrival change, means I am just changing the receiver receiver side antenna position. I can think that angle of departure, like the beam pattern should depend on angle of departure, and channel gain coefficients. If channel gain coefficients gets changed, then also the beam should be changed. So within a coherence time, none of these will should change. If any of these change, like the information of the particular beam form will get changed. So the correct option will be, anything should not be changed. So all of the above. So the right option is option D. So this was all for today. So anybody has any question, extra question? Okay. And the practice questions I will ask for the I will ask you guys for one more week. Like after 1 week, I can approach the professor, because right now holidays are going here. So After 1 week I can approach the professor for the practice questions or the previous year questions. Like this week it is impossible to contact the professor, so after that week I will do it. So except this, any more question? Yes, yes. Fifth, 64. B 64. It is 64 B. Sixth. Okay. Six is option D. Okay. We'll meet in the next 2 in that case.